Good morning, ladies and gentlemen from sunny Prague. My name is Jaroslav Broš and I will be your guide in today's webinar, which is named Effective Input of Climatic Loads in SCIA Engineer. Before we will start with the interesting topic which is related to climatic load, there is some let's say housekeeping, and that's the following. During the whole webinar, your microphone is muted. If you would like to ask some questions, and we appreciate it, please use the question box which is here highlighted, and then you can type your question and we will reply it. For the reply of the question and also support me is here my colleague Peter, and who he will be answering during my presentation. This webinar is also recorded, and at the end it will be posted on our SCIA YouTube official channel, where you can find it and you can replay it or recommend it to your colleague if he is interested in the topic of the climatic loads. So that's mainly related to some housekeeping and the things around how the webinar is organized. And let me go directly to the current topic, which is the climatic loads. As you can see on this funny picture, the climatic loads, mainly when we are talking about it, it's the wind load and the snow load are also one of the important loads in the case of the designing of the structures, because it may produce some disaster if it will be omitted or, let's say, wrongly calculated or not taken properly into account. What will be content of today's webinar? That's very easy. It will be how to set inputs for wind load, how to calculate the wind load in the case of a freestanding wall, to show you some basic principles which are behind the settings and also behind the calculation in SCIA Engineer. And let's say at the end we will see the wind load and its application on a steel hull. So what's important to say is that for the usage of climatic loads, you need to activate the climatic loads in the functionality. We will see it very soon in the application, and then in the actions you need to do some, let's say, basic settings and basic changes for the wind load and for the snow load. Here you can see the setup manager, which I will describe you directly in the application. So let's start with the application and with the presentation of the design of the steel freestanding wall. So as I already told you during the PowerPoint presentation, in the settings you need to activate the functionality tab, and here you need to select the climatic loads. Once you did it, then you can easily switch to the actions. Here is the wind load and all the possibilities which you have. I would like to design the wind load according to the code. It will be Eurocode plus the Belgian national annex. If I will click on the three dots, I will see the dialog which shows me all the inputs which are taken from the national annex, or there are some settings which needs to be inputted from me as a user based on the code procedures which I should follow. Basically, all the things which are, let's say, this for me it's a green color, which are in this green color that's somehow related to the Euro code and the national annex. So that's are all the parameters and the things related. As you know, for the design or for the calculation of the wind load, it's very important to know in which region, let's say, you are designing or calculating your structure. As I have mentioned before, I'm using the national annex for the Belgium because for the purposes of this demo, I select the Belgium and the Hasselt because that's the headquarters of the SCIA. So let's imagine that we are designing the freestanding wall and then also the steel hull in the city of Hasselt. Here you can see that the Hasselt is in the area where the wind velocity, the basic one, it's 25 meters over the second. So I need to know this value to be able to fill it in the dialog here. So that's I already did. I have the selection from these values which are related to the annex. If you are using the different annex, for example, for Czech Republic, then the values will be different based on the annex. So then also there are some others, the Germany. So you need to select the basic wind velocity. Then what you need to also do, it's the selection of the terrain category, as may be seen also from this graph described in Dutch. Here you have the different categories which shows the dependency on the wind speed and the height of the structure, and also based on the category of the terrain, which goes from the 0, which is the sea, to the category 4, which is the stud. So I will select the for my purpose the terrain category 3. If I will follow then you know that in the case of the wind calculation, the code prescribes some differences in the case of the, let's say, the building geometry and also the height of the structure. So you have, let's say, the three basic types in the case of the building height. If the height is below the width of the building, or if it's in the interval between the width and two widths, and then if the building is significantly higher than, let's say, wider. For my example, I have the width of the structure 2 meters and the height is 10 meters. All this I'm saying because now I'm currently clicking on the OK, and once I do it, I would like to know which, let's say, the wind curve or the distribution of the velocity, or how you can call it, is according to the code and what will be used in the calculation. That I can do it, and I can, let's say, check it if I will just switch it to the user defined, click on 3 dots. And here I already have the curve type, which is named as an Eurocode. That's basically calculated on the inputs which I have inputted through the settings related to the code. And here you can see that the height is 10 meters, and I have this distribution of the wind pressure over the height of the structure. What's important, and what was also, let's say, visible on the dialog for the wind settings, is that there is the item which is related to the width of the structure. The basic default and the default value on the dialog is 100 meters. But we have 2 meters, and as you have seen from the presentation, it's let's say the important value once you are determining in which of the 3 items your building or freestanding wall is. So it's really important to take care about the values which you are inputting into the calculation. So here 2 meters, and then it will produce this wind pressure curve. So you can easily check it if it's okay and if it's as you expected during your calculation. So I will close it, and I will go back to the settings according to the code. That was the first what I need to do in the case of the calculation, and then I model my structure, and once my structure is modeled, as you can see here, and I have the 2D element. Once I have the climatic load activated, and I have the structure modeled here, I have the settings for 3D wind. It's checked on, and it produced me that there is a small arrow which shows me that there are some inputted data for the wind calculation. Mainly it's related to the type, because I can select that the 2D element as it is now could be wall, roof, parapet, or freestanding wall. In most of the cases, that's let's say recognized automatically, as you will see during the steel hole demo. So here I just select the freestanding wall, and then here I have the solidity ratio, which represents how the freestanding wall is solid, and that's related then to the calculations. I can select it for the value from 0.8 to 1, which represent the solidity ratio. So that's it. In the case of the other examples, it's also then important to take a look at this parameter, which will signal what the outer surface of the element is. So I'm pretty okay with this. And then what I need to do is to click on the load. Then I will get the basic content of the loads, where the ZS1 is the self-weight load case. I would like to produce the 3D wind. I click on it, then I need to add some load cases, and here I can play with it as I would like to define some wind load directions. For me, in the case of this example and this freestanding wall, it's let's say the most important, the first one, which is related to the zero direction, and that means that the wind is blowing in the same direction as it is the direction, or as it is the x-axis. Then I can also produce some other load cases which are perpendicular or the opposite direction, etc. For me, in this case, it's not important. Also, these additional load cases for the dual pitch roofs, it's not important because we are now handling the situation with freestanding wall, so no roof needed. I can easily delete this line so that they are not important, and I can, let's say, degenerate the wind load cases based on just this one direction. So the 4 load cases are generated. It's also related to the combination of the internal and external pressures. So I have the 4 load cases generated, and they are prepared for the generation of the load. So I can run the generation. The wind load have been successfully generated. What I can do, I can also have a look on the generated load with which is now displayed here. It's related to the parameters and all the settings which we have been done. Once I will, that's the prepared. Once I will press the button related to the generation of the mesh, or also run the calculation, the load based on the coefficients based on the wind curve. It's generated and it's ready for the calculation. So here you can see which values I have generated. So that was perfectly okay till now, related to the generation of the wind load for the freestanding wall. I will run the calculation just for this generated load cases plus the self-weight to demonstrate to you that there is also one possibility how you can also have a look on the loads which is generated with the help of so-called 2D data viewer. So we are just now waiting on the finite element calculation. Once it will be done, then we will have the access to the results and access also to the 2D data viewer. So it's almost done. Once it will be ready, we can have a look. Okay, so calculation is finished. Then I can switch to the main tree, and in the main tree I have accessible here under the calculation and the mesh 2D data viewer, and I'm interested to know, let's say, the distribution of the surface load for the let's say this wind load case. So I will just select, as I have displayed the wind load here and there, and I would like to know the value Qx, which displayed after the click on the refresh button, and here I can see how it's changing the loads along the height of the structure. So we can see that the wind curve, which we have been defining at the beginning of our demo, is taken into account. So you can see that it's changing over the height. So it's from 0 to B, from B to let's say double B, and then the rest. That was everything what I wanted to show you related to the free-standing wall. There is also a possibility to include this basic information, unfortunately without this wind pressure, but as you can see, you can use also the screenshot or some other help that you can include it into your engineering report to describe how you calculate the wind load according to which national annex and which coefficients which you used. So let's start with the steel hall example. Before we will jump directly to, let's say, the real steel hall, let's try a bit a small clarification related. I have this let's say the steel hull, which is modeled from 2D elements, just to demonstrate and be a bit transparent what is behind all the calculations which are happening in the generator. So if I will go back to my presentation and show you some pictures which I have taken from the code. So basically, in the case of a steel hall, which is a building with dual pitch roof, as you have seen, on the presentation. So you have the different zones, and then also there are some geometry conditions which needs to be taken into account, and all the things related. So this I have on the picture in the code how it should look like in my case. So I have this structure. For that, I just simply select all the plates and saying, okay, I would like to use the 3D wind for all the 2D elements. Here I just need to say that, well, it's not monopitch, it's a dual pitch roof, and I would like to also take into account some roof overhangs which I already have modeled. So I will go back here. And then the rest of the elements are taken as a wall. And as I have been talking about this option swap outer surface, you can see here that this small blue arrow is going inside the building, which is the wrong direction that it should go out. I can just say here that I would like to swap it, because it shows me where is interior and where is exterior. So if I quickly check, then I need to do it also here. So just click on the arrow and swap the outer outer surface. Now I have my structure, which is, let's say, solid, and I can start with the same procedure as I did for the freestanding wall. So I have my wind curve generated, and if I will just let's say quickly check what's inputted, here you can see that I already changed the width of the structure to really take into account all the things which I need to. Okay, that's it. And now I can go to the load. Once it's opened, I can go to the 3D wind generator. I can click on the add load cases, and in this case I would like to really know, let's say, the behavior of the structure which is subjected to the wind load, and I would like to know all these wind directions. And because it's it's included the dual pitch roof, I would like to also take into account some additional load cases. And here is the little settings which is related to the generation of the additional load cases for dual pitch roof, and I need to define the direction of the ridge or the truth of roofs, because I have just one roof, and if I'm not mistaken, the direction is in the global Y. I can just select this one, and it will reduce me the number of the load cases which are generated then for the combinations. So I have the basic settings done. I can click on OK, and I need to await a bit then for the generation of the load cases. So I have 32 load cases already included. And here you can see all the combinations which are taken into account. If I'm let's say pretty sure what I'm doing, I can also, let's say, neglect or to deselect some of the combinations, which can also reduce the number of the load cases. Now I just need to push the button for the generation of the load cases, and then wait on it to be able to see the results. So the wind calculation finished successfully. I'm interested to know how it looks at the screen. So I will select the first wind load case, let's say, which is in the direction of the 0 in the x directions, and here I have produced the load which then will be used for the generation. So now I'm interested to know, and I would like to know how to check the dimensions of the wind zones, as you can see here here on the picture. That's a bit handy to know how to do it. If I will go to the setup dialog, and then after a bit of searching and switching to the group which is called loads and masses. Here it's the items related to the wind data. So I would like to display the wind data. I would like to also display the values and all the things together. So I click on the apply, and now I have, let's say, the pretty clear situation on a monitor to see where the zone D is, where the zone E is, and which CPE coefficient is used for mentioned zone. What I would like to also know is the possibility to see the dimensions of such a zones, like how long the zone A is. So I can easily use for it the tools which we have in SCIA Engineer, and that's related in it could be, I guess, also done with the coordinates, or I can go to the structure and use the dimensions here. So dimension tools. I have it to not waste the time. So I use the dimension tool, so I know that the A is 3 meters, and that's what it should be according to the code. The same I can also do for the zones which are on the roof for this small zones, that I can use the dimension lines to be sure how it looks like. So if I would like to know also how it look for the different directions, so I will scroll down a bit in the list of the load cases. So now you can see that it's slightly different than the previous one, and the wind direction is parallel to the y-axis. So the dimension lines are not valid for such a case. So I will do the same, that I will use the dimension lines for it. And if I will close the dialog, you can see here that it's 3 meters because it's E divided to 4, and you can easily found what is the E. So that's basically what I would like to demonstrate with this, let's say, the building created from the solid 2D elements. It's also nice to mention that if you have the concrete building with 2D elements, you can use these 2D elements also for the generation of the wind load. As we are speaking about the steel hull, let's have a look on example of the steel hull which I have from my colleague. So it's the structure, or the object, is with the same dimensions as we have seen before with the solids, let's say solid 2D element. What's important to say is that in the case of the steel hull or the steel structures, you usually model 1D elements like steel columns or some elements of the roof, and you are not modeling 2D elements, but 3D wind and wind load generator for 3D structures works just with 2D 2D element in such a case. So you need to create the envelope of a structure, and that's the right time when you can go through to the structure, and you can discover the group which is called load panels. Load panels are such an elements which are transferring the surface, the 2D dimensional loads into the loads which is applicable on 2D, or sorry, 1D elements. I already did it, and here I have my structure, which is already accompanied with the load panels with the tributary area distribution method. So once I have the load panels defined, and I will try to zoom it and select the one here. You can see that I have also the option that it could be used for 3D wind. Then I can have also the option what I would like to take into account in the case of the distribution of the load, which is generated based on the 3D wind load generator. So I have it done. I have my load panels, so I'm ready to go to the service load, and then do the same which I did before. I will just erase this what I have here to demonstrate what I want to do. So I have just one load case self weight, and then here I have the option for 3D wind load generation. Well, I can do the same as before with the selection of the directions and combinations of internal and external pressure, and also because of the dual pitch roof, I can just say that it's parallel to the direction of the global y-axis. Okay, and the load cases will appear in a while. Let's say as I'm speaking now. So I have load cases generated. Then I just run the generator on the background, and we will see that we will obtain the same loads as before with the same structure. So if I will switch it here, it should look like familiar for you. Once I'm done with all the modeling, with all the loading, I can then just push a button for the calculation, and all these aquamarine loads will be used, and the loads for 2D for 1D elements will be generated. So I will push the button for the mesh generation. Once the mesh generation is being done on the background, then also load transformation is provided. If you would like to, you can do it also manually, as you can see here now during the generation of the load. Here I have also the possibility to generate the loads for the selected load panel. So once we will be waiting on the generation, that's what I have shown you, that it's possible to document the zones and the values, and then via the live picture or via the screenshots to import it to engineering report to document how you calculate the wind load. And also here I have just the tables from the code, which shows which values I can use. So I have heard bell in my headphones as the dialog appears here with the mesh generation done and with the generated load. So I click on OK, and I'm done, and I can let's say proceed also for some designs and some other things related. The questions may be that we have been named, or we are talking about the climatic loads. What I can do in the case of, for example, the snow load, then there is an option. If I will go back to the loads, and via the three dots, I will just generate the new load case, and that's here. It just takes the name of the last one. I will just name it snow. Here's snow. Snow was a description. It's like, yeah, it's set its variable. That's one perfectly okay. But I would like to tell to the system, well, it's a snow. It's not a static when the specification is a snow. No, I don't need to 3D wind for this load case. So I have my load case for snow ready. Then what I need to do is that I will go to the surface load, and then, for example, 2D surface load on 2D member. Here I have the snow. I need to know the value of the coefficients, and based on the settings which are in the dialog for the climatic load, I can just directly input the values which are calculated based on it. Then I spent some time, or the majority of the time of the webinar related to the 3D structures. The question could be, well, what in the case that I'm working just with 2D frames? I don't want to model the whole 3D structure. How can I do it? How can I simplify it? What I should do? Should I model the whole structure? Well, the solution is here. If I will just focus on one frame from this steel hull, it looks like here, and I will just create the new load case, and just rename it and go back to the static snow. So I have the load case where I would like to somehow model the wind load. So I can do it, and now I can go to the wind load generator. It needs let's say says me that I need to change the working plane to be in plane XZ or plane XY, and let's have a look if I'm able to change it. So I need to switch it to, I guess, this one, if I'm not mistaken. And now what I need to do is also to tell the system the frame distance. So here you can see that I have 4.5 meters. So let's tell that it's 4.5. And now I select the wrong one, so I need to change it. That's what I have bet selection. So for my mistake, now it should be okay. So that's just because I don't know the coordinate system and how it works properly. And here you can see the 2D representation of my frame and all the coefficients which are related, and they are related to the zones, which is let's say here, not at the beginning one, but I can change it. That I will just go next, and here I can rewrite the coefficients. So I have here the system which defines me how it will look like. I can just say okay, and then it will be applied. The same I can also do for the snow generator. I hope that I will be okay with the selection of the working plane. Here you can see that the coefficient is 0.8, and I can also change it, and I can also say which load mode it should be. And that was all what I want to present you. Actually, the load was generated for this frame, and that was done because of the coordinate system is located here. So if I would like to also generate here, then I need to have the coordinate system inputted here. So that's a possibility that I have just 2D frame. I can use this simple 2D generator. So I have the wind generator, snow generator, and wind and snow generator. And these three generators are working on 32-bit version exclusively. 3D wind works in 32 and 64-bit. That's a bit the limitation of the usages. And that was all from from my side, we have 10 minutes left also for the questions. So I just have a look what we have, and if everything is answered. If you will have also some question at the end of the webinar, you can reach us. You can reach us through the mail on a support or call us. So I just need to do it. So there are some questions on a complex structure. This method has potential to generate thousands of combinations. Is that true? Well, it will not grow infinitely. Let's say the complexity is in the combination of the dual pitch roof and all the things related to the combinations which you needs to do. So it will not grow infinitely. Then the next one: will SCIA consider circular shapes correctly and according with the code, or will this need be to done manually? We will I think explain you later bit, and then that's okay. We will reach you in the separate mail, because I think that mainly it works pretty well and pretty good with the rectangular or the let's say the normal shape. The circular ones are a bit difficult, and what we are doing in the wind load generator is that we are identifying the structure according to the categories, let's say, which are in the Eurocode, and in the Eurocode you can find let's say squared building with dual pitch, mono pitch, or some flat roof, and that's mainly it. And if I will have a look on the other question, hello, where can I find the wind data settings for the load panels? That's basically in the case of the load panel. If I will select it, it's just below the layer. Here it's a 3D wind. I can activate it, and then once I activate it, I can see this little blue arrow, which shows me that the wind data are included on the load panel, and it identifies that the type of 2D element is a wall. If I haven't select the climatic loads in the functionality, then I will not able to see in the properties of 2D member or load panels the option for 3D wind. Okay, I would like to say many thanks that you joined this webinar, and for all your questions. If there are still some questions which are not answered, we will handle it separately through the mail. Thank you very much for your attendance. This recording will be published on our YouTube channel, And also at the end of this webinar, there is a little survey, and please, if you are, I would like to ask you if you are so kind and help us to improve our webinars and also our software. Thank you very much. I wish you have a nice rest of the day and have a lot of success with all your projects which you are doing.